We're, we're good.
Okay. Sock Springer Productions on the circulatory system. So today we're going to talk about how your circulatory system is all set up. And in your book, the circulatory and respiratory systems are tied together. That would be particularly this area right in here. And you've got your heart down the middle, and just a little bit on the setup here with the respiratory system. So you've got your right lung, your left lung. With the right lung, you've got three sections. 1, 2, and 3. Left lung is a little bit smaller because the heart is tipped over to the left, largely in the center of the body, but the apex of the heart is kind of tipped this way. So you end up with one section here and one right here. So a key thing to remember is 3 lobes on the right side, 2 lobes on the left side. Okay, so we have the heart in the middle here, and it's got its own little space. And this area here is called the thoracic cavity. And then surrounding the heart, in a little area here called the mediastinum, you have the fibrous pericardium. It's going to be wrapped around, so it's a little sac-like structure that's around the heart. So when you hear about somebody having fluid around the heart, something has happened to cause fluid to get into this little sac right here. Okay, some of the basic structures of the heart, and then we'll get into the circulation part of it. But if we're looking at this model right here, and this is in the anatomically correct position, so that this is the right side, this is the left side. Up on top, you have the right auricle, left auricle. This down here is largely cardiac muscle. This is the bulk of the pumping mechanism for your heart. Other things that we'll notice on the outside, you see the yellowish material here, that's adipose tissue. And we all have a little bit of this. A major problem occurs though if somebody is extremely obese and they get too much of this here, you're getting a buildup of fat around the heart. These are your coronary blood vessels. Red ones, obviously coronary arteries. Blue ones, the coronary veins. So the heart supplies its own circulation. And once we get to the inside, we'll discuss a little bit about where these things originate. Okay, on the outside also, if you notice there are some striations here. The heart is like a lot of the other organs where you have 3 layers that's set up on this thing. You've got a set of muscles that are going to be going this way. Below that, you'll have another set that will be going this way, and then you'll have another set that'll be going this way, largely to help with the contraction. This whole bottom part here has got to have a nice, even contraction to force blood out of there and not put undue stress on any one particular area. But that can happen, as we'll discuss a little bit later. The bottom part of the heart here is referred to as the apex. So we've got the auricles, cardiac area here, and notice I'm not using the term ventricle. We'll save that till we get to the inside. This is not a ventricle here, this is cardiac muscle. This blood vessel coming out up here is branching off this way, and then when we turn it around, branching off the other way. This is a pulmonary artery. It's coming from the right ventricle on the inside. And so you've got one branch leading to the right lung, one branch leading to the left lung. This large red one is the largest artery in the body, and that's the aorta. This particular curved area here is called the aortic arch. And then you have branches coming off of that. They'll be going up the neck, where you've got your carotid arteries, and then those split also, so you've got an internal and external one. on each side. And then you've got branches that go off to the shoulders. And you can see those right here. Excuse me, with the red. You've got branches that will go inside here. This was the carotid part going up this way. This large blue structure right here, this is a superior vena cava. And then down below here, you've got the inferior vena cava. If we take a look at our model here, this would be the superior vena cava. This is bringing blood down to the heart. So we talked about this one here. This is a pulmonary artery. And one point to make clear here, you notice this is blue, so not all arteries in the body are red, and not all veins are going to be blue. In this case, this particular artery is carrying deoxygenated blood from the heart, and then it's going to branch off and go to the lungs. So that's why you have the blue appearance. Okay, the aorta here, like I said, branched that way, so you've got a lot of blood vessels packed into a small area right here. The inferior vena cava would travel down behind these organs here, the liver, your stomach, and intestines. As you can see coming in this backside here, where it's connected here, that'd be generally what we refer to as the vena cava. So we've got blood coming into this chamber right here. That's from the vena cava. You've got blood going out from this side of the heart. Right here would be the pulmonary artery. Blood going out from this lower left side of the heart here would be your aorta. Now we've got one area then, we've got to have blood coming into the left atrium, or auricles. And those are these right here on the back side. These two are coming from the left side, so these would be the left pulmonary veins. And like I said, not all veins are blue. These happen to be red because they have oxygenated blood from the lungs. These would be the right pulmonary veins, obviously coming from the right lungs. So that takes care of the bulk of the exterior part of the heart. Once we open this up, and we get in here, like I said, this is the apex down here, and a good signaling point. If you notice, this is narrower than this, right here and here. So when we go back this way, we're opening it up. Remember, left side of the heart, right side of the heart. The left side of the heart, the cardiac muscle, is much thicker than the right side. So if I dissect the heart down the middle, then you're going to notice a definite difference there. You should be able to pick out the left from the right side. The wall that's traveling down the center of the heart, right here, that's referred to as the septum. And it tends to get a little bit narrower once you get up towards the top. This is the last part that's going to seal off before you're born. So when you're in your mother, blood could travel back and forth here. And the key point regarding that is that the baby does make its own blood. Babies don't get their blood from their mother. They make their own. So it's an independent setup, and with genetics, that's a source of discussion too, depending on what the mother and the father's RH types are, but that's a whole different set of problems. So we've got then on the inside the right atrium, the right ventricle and the left ventricle. Ventricles are referred to as spaces, and you do have other ventricles in your body, particularly up in the brain. You have 4 sets of ventricles up there, and they're just spaces that are filled with fluid that help with the cushioning up there. In this case, these are collection areas for the blood. So blood that does not have oxygen is coming into this side right here. from this upper chamber, going down in here, and then it will get pumped out through this valve that's up on the inside there. That would be the right semilunar valve. Okay, blood got down into this chamber from this atrium up here through this valve area up inside, and you can take a look down inside there. That would be the tricuspid valve on the right side of the heart. The little strands that you see that are right here, those are referred to as chorda tendineae, and they're hooked up to little muscles down in the ventricle that are called papillary muscle. You can see the little bumps that they're connected onto. The primary function for these are kind of like little bungee cords hooked up to the valve, and you don't want the tricuspid valve to collapse and fold backwards when the heart's beating. So they kind of anchor it in place. And you've got the similar situation on the left side over here. Okay, and those particular valves then, okay, this one right here, like I said, is the right semilunar valve, or what they call the pulmonary valve. This one right here is going into this large red aorta. And so this is your aortic valve, and that's carrying the blood from the body. You can see little cups right here. A lot of these valves, the pulmonary valve and the aortic valve, they're catching the blood between heartbeats so that it doesn't go back into the heart. Okay, and then on the right side, if we can see down in here, left side, seeing down inside here, we rearrange here, where the pen is pointing. Okay, that is the bicuspid or mitral valve. So blood going from the left atrium is going to travel down through this, gets to the left ventricle, and then this little valve will close up in there. Then the bottom part of the heart will contract, and then both sides are sending blood out at the same time. This side will go to the lungs, this side will go to the rest of the body. So to put everything together, and I guess one thing before that, you have different layers of the muscle I explained earlier that are going down at an angle to the right, at an angle to the left, and then vertically down around the heart. And that's so on the outside, you have the epicardium, and then the inside is the myocardium, and then the very inner part is the endocardium. And you may notice these little lines that are going through here. Those are nerves that are helping with this whole heart contraction business. On the upper part of the heart, located in about this area here, there'd be a little bundle of tissue called the SA node, or the sinoatrial node, and that gets a message from the brain, particularly the brain stem area, and it sends a message down, and it will cause these two chambers to contract at the same time. So you're going to send blood that's in these down to the bottom part of the heart at the same time. That goes down there. The message travels from this area down into this area here, which would be the AV node or atrioventricular node. And then it's not like you have contractions going on here, here, all the way around. This is kind of a delayed reaction type circuit. So if the message hits here, zips all the way around here, gets everything stimulated at once, so you get a nice even contraction. So blood's coming into the heart, these chambers here, message occurs, they contract. They send blood through the tricuspid valve and the bicuspid valve. It gets down here, the valves close, and then the message travels around, contraction here, blood sent out to the lungs through the pulmonary artery here, and blood sent out on this side to the aorta at the same time. So you may have heard that little deal, tracing a flow of blood, a drop of blood flowing through the heart, and that you would start up here and they work their way around and go out and then come back around and down here. Well, in real life, this is receiving blood, the message comes along, it contracts, forces it through the valves at the same time, it's into the bottom chambers, the message comes around, cardiac muscle contracts, forcing it out of those ventricles at the same time. So you got a couple of things going on here. That's where you get your lub-dub sound. So when the heart's beating, you hear a lub-dub, 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 lub-dub. The stethoscopes, if you take anatomy and physiology next year, you'll get a chance to use the stethoscopes with Mr. Springer and be able to listen to your own heart if you haven't had that opportunity so far. Some other things here then. I can show you. So we talked about the circulation of blood around the heart. Okay, how does blood get into these blood vessels? Well, right around the aortic valve area, if you can see these little spots right here, there'd be 4 of them around the heart here in this area, and you've got 4 main arteries coming out of that aortic valve area that supply the coronary arteries. And then when blood is coming back to the heart, and it's not on this model, but you'll have areas where that blood then from these blue lines is going to connect into the right atrium up here. So that's how the blood, or how the heart takes care of its own blood supply. Now, things that can go wrong with the heart. Okay, on the outside here, you see the fat. Okay, arteries are the main concern when you're talking about somebody having a heart attack. If I would end up with an area that's blocked right here because of fat buildup on the inside, to take a look at this model, this is what a nice, normal, clean blood vessel should look like. As you get older and things start to build up inside, this gets a little bit thicker and a little bit thicker around in here. You see the yellowish material, you get some plaque buildup, fatty materials in there. And it gets thicker. And so I've only got blood that's able to flow through here. And ultimately, if you get to the heart attack stage, you're about like this, where hardly anything is going to come through. And if that was occurring down in here, then this part of the heart would experience an extreme lack, maybe no circulation at all. And you'd start getting some severe pain. Down in this area like this, then you might have what they call a minor heart attack, or minor cardio infarction. If it's happening up in here, a larger area, you could end up with a major heart attack. And one thing I wanted to point out with the blood vessels, they're arranged like a lot of other things in the body. You've got 3 layers also, 3 little muscular layers of smooth muscle that make these up. So when the heart beats, this is going to expand when blood's gone through, and then it gradually pulls back down to keep blood flowing through the rest of the body. So this buildup that's going on here is called atherosclerosis. Once it starts to harden and get more solid here and ultimately block in these areas, then it's called arteriosclerosis. Other things that can happen. If we go to the inside of the heart, you may end up with these valves up in this area here, and they should seal up nice like this when they open and close. They could get damaged by bacteria and cause some stiffness on the sides of them, and so when they close, they're like this, and you've got little spaces here, and that can let blood swish back upwards. Okay, you can also end up with mistakes in the pulmonary valve and with the aortic valve. Okay, a major problem with this one is that if blood is slipping past this, now you see them sealed up here real nice, smooth. If I've got a little gap here and some blood can slip back down here into this area, that can start putting some undue pressure on the heart, and it can stretch this area out like this. So if you hear of an enlarged heart, that could be one cause. Bacterial infections could end up being another cause, and end up with a situation called pancarditis. But a major problem is this aortic valve leaking blood down there, and if it is, that's what they also call a heart murmur. Okay, the part where if this valve is affected right here, it's going to let blood go back up to this chamber right here. That was receiving blood from the lungs. If you remember, your right and your left pulmonary veins come in there. If I get a backup pressure here, that's going to back up pressure in the lungs, and it's not going to allow for proper action to take place there, and it's going to squish out some of the plasma in the blood vessels and in the blood there and force it into the lungs, and you can end up with a situation called pulmonary edema. Real bad situation. Person's in severe need of medical help when that happens. Okay, other things that can happen. Remember I said there's this little bundle of nerve tissue up here, the SA node, sinoatrial node. That could be out of whack and cause problems with the heart. Sometimes the heart can start quivering, and especially the upper part, they would call that atrial flutter. If it happens to quiver down in the bottom part, that would be ventricular fibrillation. And in either case there, with a constant fluttering like that, you're not getting even contractions, and so you don't get a nice even flow of blood going through the body. Now, the last thing I'd like to say is that the heart is set up on the all or none law system. You should have about 80 milliliters coming in here on the average person, and about 80 milliliters coming in here, which means that when they contract, each side is sending down 80 milliliters here and 80 milliliters here. When the bottom contracts then, sending out 80 milliliters to the lungs, sending out 80 milliliters to the rest of the body. Okay, so the all or none. You don't have parts and differences there. 80 coming in, 80 going out. Where you end up with some slight problems, like I said, with a heart murmur, and this part gets stretched out here. You don't quite get the same thing working. You start creating an imbalance, and that can lead to a whole host of different problems. So hopefully you gain a little knowledge of the heart and a little better understanding. All of us at one time or another will end up in the doctor's office talking about maybe high blood pressure, some valvular problems. You may have kids later on in life, hopefully not. But I've had some cousins that have had situations with the heart. The septum may have not been sealed off properly, and so they get blood flow going back and forth here. And you might think that's not a big deal since it's in the heart, but mixing the blood without oxygen with the oxygenated blood can cause a problem. So we'll leave it at that, and hope you have a little better understanding of the circulatory system.